All right, so today we're going to start chapter 10. We're going to talk about lines and segments that intersect circles. Today is going to be a lot of different types of vocab that will be used throughout the chapter. So really important foundational things, skills, vocab to understand as we move forward with the rest of the chapter. As we talk about circles, some of the stuff you guys have probably already heard of before, but first one we're going to talk about is a radius. When we're talking about a radius, talking about any segment that is at the center of the circle and goes to the edge of the circle. There are multiple radii, many radii that could be in a circle, and they are all congruent to each other. Next one is a chord, and a chord is a segment whose endpoints are on a circle. So a segment starts and stops, and it must be on the circle. Which leads to the diameter, because that is the longest chord in a circle, because it does start and stop on a circle, except for the fact that it must also go through the center point of the circle. The next few are talking about vocab, more of lines in circles, and so the next one is a secant, which is a line that intersects the circle at two spots. So when I draw a line, I will go through the circle twice, and it touches at those two spots. Another line that could touch the circle is a tangent line, but a tangent line is a line that only touches at one spot. And so in this case, it'll touch at point B, and then that means that point B is called our point of tangency. So it's where the lines are tangent. So using all of those vocab words that we were just talking about, go ahead and pause the video and attempt to solve A through D on your own fairly quickly. So segment PR, number or letter A there, as I draw PR, that is the diameter of the circle. And then when I look at line MN, draw line N, it only touches at point R. So that is our tangent. And then R, just for reference there, R would be called our point of tangency. And then when I look at line PQ, the line that goes on forever touching those two spots would be called our secant line. And then segment QO is our radius. One that was not on there, but we could go over again if I was to change QP and just call it a segment QP. So in this case, it would start on Q and end at P. Then that would be called a chord. Some other vocab dealing with multiple circles and tangents in circles. Different ways that you can have circles touch or not touch. So the first one there, you have two circles and they have 2 points of intersection. You could also have circles that touch exactly one time. They could be one of them could be inside the other one, or you could have two circles that are just touching at one point at the same point. And then you can also have circles that will not touch at all, so just draw them away from each other, or concentric circles, which are circles that have the same center point. You can also have common internal and common external tangents within the circles. And so we can talk about those in number 2. So keeping that vocab there. Number 2A, we cannot draw a tangent to both of the circles. Because if I draw, for example, that line, that is tangent to the small circle, but then it would be secant to the large circle. And it would be like that in any line that I draw, best case. So there are no common only tangents to both circles. In B, I could draw exactly one line, and it would be that line that is tangent to both of those circles, and so that would be our one common tangent. And then for C, we could have both internal and external tangents. So the internal tangent would be in between the two circles. So those would be called our internal tangents. But we could also have external tangents, which would be above or below the circles. And those would be called our common, because it's tangent to both. It would be our common external tangents. And then some other vocab, you don't need to know these as theorem numbers, but you do need to know how to apply these. So reviewing what we talked about just now, line M there is a line, and it is tangent to the circle at exactly 1 point P. If I draw a radius to that specific point of tangency, it will always create a right angle. So again, if I have a circle, I draw the tangent line there, and it's tangent at that specific point. If I draw the radius to that point, so center to that point, it will always create right angles. And then the second one is dealing with the external tangent from the same external point, which is sometimes referenced as the ice cream cone theorem. So this is our external point. We have tangents, external tangents on both sides. So those two segments must be congruent to each other. So number 3 is going back to that first one, dealing with perpendiculars. So this one, though, is asking, is it tangent? It's not telling us that it is tangent. So is ST tangent to PT? To the circle, which would be the radius. And if that is true, then that would need to be a right angle. So it would need to be perpendicular if true, which would mean that triangle STP would need to be a right triangle. So because we know how to prove right triangles, we can check to see if it's tangent. And in order for that to be true, we would have to do 24 squared plus 44 squared would need to equal 51 squared. And we can verify that that is not a true statement. So ST is not tangent because it wouldn't be perpendicular because it's not a right triangle. In number 4, a little different, it is telling us that point P is tangent. Therefore, by rule, drawing the radius to that point of tangency has to create a right angle, which means that we could create our right triangle. So in order to solve for the missing variable, we could use our Pythagorean theorem, this time knowing that it is a true statement. So r squared is one leg. 36 squared is our other leg. And then the entire hypotenuse is r plus 24. So using our calculator, we can get that r squared plus 1296 equals. Now you do need to remember to distribute the r plus 24. Now, works out nicely here that our r squareds are going to cancel. When we move the 576 to the other side, we're going to get 720 equals 48r, which means our radius is 15. Last one, for number 5, we're talking about the common external tangent, which means we're going back to theorem 10.2. So go ahead and pause the video and solve number 5. So because we have external tangent, JK is a tangent and JH is a tangent. So they're both from J. That means that these two segments must be congruent to each other. I can solve for X. So make sure you go back and review any vocab that you need from this section. It's going to be crucial that we know the vocab as we move forward for the rest of Chapter 10. And make sure you complete any other work for 10.1.